station, this is Houston. Are you ready for the event?
Houston, we are ready.
UCLA, this is Mission Control Houston. Please call station for a voice check.
Station, this is Anil Nair.
And Annalise Peterson from UCLA Samueli School of Engineering. How can you hear us?
UCLA School of Engineering, the space station has you loud and clear.
All right, hi, Megan and Shane. We're calling from the Rocket Engineering Lab here at Megan's alma mater, UCLA. My name's Anil, and I did my undergrad degree here in aerospace engineering, and I'm currently working on my PhD here in rocket propulsion.
And my name's Annalise, and I am a senior, and I'm about to graduate this June with my Bachelor's of Science in Aerospace Engineering, and we're so excited to get to talk to you this morning. How are you guys doing?
We're doing great, Anil and Annalise. It's a delight to welcome you aboard the International Space Station today and tell you a little bit about what life in space is like. I'm just really happy to be speaking to the Bruin engineers.
All right, so as two fellow Bruin engineers, we hopefully have some questions for you that are a little different from what you might usually answer. So I'll hand it off to Anil for the first one.
All right, so our first question kind of relates to how, it seems like we're entering a new era of human spaceflight with the crew capsule and the Starship. So we know that both of you have been going to space for a while now, going back to the shuttle mission. So we're wondering, what's changed about spaceflight in the last 10 years?
So for me, my first flight was on the Space Shuttle Atlantis, which was amazing. We came up and we fixed the Hubble Space Telescope, which is still operating, which I think is incredible. And then, of course, my second flight coming here was aboard the Crew-2. So the two vehicles, of course, are very different. They have very different capabilities, but one shared capability, which is to get people to low Earth orbit, and in our case, to the International Space Station. So, the space shuttles were designed, I think, in the 1970s, right? And so, older hardware, older technology, but capable of bringing people and hardware into low Earth orbit. And then, of course, the SpaceX vehicle, the Crew-2, much newer, designed more recently. And, you've seen it, I'm sure, so you know that it looks much different. The space shuttle filled with switches like an older airline cockpit, and the Crew-2, with all the touch screens. So the look is very different. The feel is also very different. The space shuttle is a tremendous amount of energy. It's a very big set of rockets, and so you're kind of like a rag doll for part of the ride, rocking and rolling. And then the Crew-2, a smaller rocket bringing just people and not big piles of cargo into space, was a very, very smooth ride.
All right, awesome. Our next question, specifically for Megan. So the three of us, me, you, and Annalise, we've all gone through the same aerospace engineering curriculum here at UCLA. So we were wondering, how has your UCLA engineering education affected you as an astronaut? And what part of your education do you use the most?
I think absolutely my engineering education has contributed certainly to where I am now and to the career path that I took. Specifically, I think the thing that I learned first at UCLA was really how to work effectively on team projects, and that is what we do all the time. And so being an effective member of a team, and in our case, I was part of a club. Basically, we built a human-powered submarine, and we had to do the fundraising, we had to do the design, the building, the testing, everything. And so contributing to all those different phases of the project and really working together effectively as a team was something that I learned how to do first at UCLA. So that's been a huge part of my education and my career.
All right, so as engineers, if we were tasked with designing the next iteration of the space station, from an astronaut's perspective, what changes should we make?
Well, that's a good one. I don't think I've ever heard that question before. That's really good. A lot of it, we have a lot of storage problems up here. We call it stowage, but there's just a lot of stuff, as you probably can see. So we designed maybe a few areas where we can just have better organization and stowage. Cable routing, yeah, there's a lot of cables everywhere up here, so maybe we'd have a better way to route the cables. Our food's pretty good, but we can always improve on that and keep getting more variety of food. But design-wise, this is pretty amazing, honestly, that we have all these modules up here from different countries that all fit together, and they were never tested on the ground. So it's a real tribute to the engineers around the world who designed these modules and designed them to be fit into space together for the very first time.
All right, so I've read that it takes at least 5 years of training for an ISS mission, as well as a impressive career before that. And I'm sure that the training is incredibly thorough, but what, if anything, about the actual launch or living in space was most different from what you were expecting?
I'll start. I think Megan can probably add a few things too, but for the launch, you never can experience the launch in a simulator. So until you ride that thing and feel the G-forces and the accelerations, you just don't know what it feels like. So, and we don't do it very often, right? So Megan's done it twice. I've done it 3 times, and that's pretty good for astronauts. So we don't get a chance to, oh yeah, it feels like this. Now the shuttle, like she mentioned, was much more powerful than the Dragon Falcon 9 rocket, but it was still, both were incredible rides. I know I was laughing and giggling all the way up those 8.5 minutes to get to space, and we were having a great time on the Dragon the other day during the launch.
So, and for me, once arriving here at the space station, it's so much bigger than the space shuttle. Obviously, the interior volume of the space shuttle where people live is actually quite small, but the interior volume here where we live is huge. And so I really had to learn to fly all over again because you just have to use different maneuvering. And, of course, there's a lot more people and a lot more stuff. And so you have to get good at controlling your rate and controlling your turns and being able to brake, And so it takes it's a learning process, and I feel like I'm still getting better and better at it every day. At least I hope I am.
All right, yeah, thanks for those answers. So our next question relates to, so we know that in our experience here on Earth, running experiments and testing rocket engines, we learned that, things don't always go as planned. And often as engineers, we have to improvise and come up with solutions kind of on the fly. So we were wondering if you guys could share, one of the most creative ways you've solved a problem in space is.
So we face lots of little challenges or things not working exactly as expected almost really every day. And fortunately for us, there's a huge team of creative thinkers on the ground that are thinking about, and they know the hardware oftentimes much better than we do. And so they're trying to think outside the box, think outside the procedure, and come up with a way for us to fix something. But oftentimes, you're right, we kind of have to come up with something on the fly. So when we're running procedures for principal investigators who are on the ground and have never been into space, sometimes things don't behave exactly as they're expecting, and so we have to come up with things to help make that experiment successful. So an example that came up recently was, we're trying to move a plate that had some liquids on it and trying to make sure that we didn't disturb those liquids as we moved it, because that, would impact the science, of course. And so I thought of something that I do at home when I'm making brownies. I make a sling for the brownies to pull them out of the pan very gently. And so we were able to do something similar with some tape, basically, to be able to move this equipment, this experiment equipment around sort of very gently without disturbing. So we'll find out later today if we were successful. So I'm very hopeful that that solution worked.
All right, thank you. So I mentioned this before, and this question is directed at Megan, but I'm about to graduate, and I was wondering how the industry has changed for women over the course of your career, and if you have any advice for me and my classmates as we enter the full-time workforce.
That's a great question, and I really have. So I've been a full-time employee at NASA for 20 years, and I had one, summer co-op, summer job at NASA, when I was an undergraduate at UCLA. And so in that time, which is a long time, I've seen basically the biggest thing that I've seen, the difference that I've seen is more women in the workplace, in the engineering and the technical jobs, and more women in leadership roles. So when I walk into any given technical meeting at NASA now, there's a high percentage of women, and there's there's oftentimes a woman running the meeting. And so that in itself has just been a big change in the environment. And so I hope that all young people that come to work, for example, at flight operations, which is our division, they walk in and they feel comfortable in that room. They feel like they can express their opinions. I think that the environment is such that everyone is encouraged to speak up and to bring their ideas to the forefront. And I hope that that's how young people, men and women, feel when they're coming to work at NASA today.
All right.
All right. Thank you so much.
Thank you. Yeah. So I was wondering what you guys are most excited for about the future of spaceflight, and do you guys plan on going to space again?
Well, it's a great time to be in the space business. This next decade is going to just be unbelievable based on the trajectory that the space business is on right now. As you know, a lot of commercial and private companies are building spacecraft, some to take people, some to take satellites and other things to orbit. And so it's a really great time to be in the space world. As you may have heard, there's a flight coming up in the fall called Inspiration 4, which is going to have three non-professional astronauts that'll launch on a SpaceX vehicle into orbit. So that's going to kind of open up a lot of doors, I think, and maybe the pathway for the future to give access to more people to this incredible thing that we get to experience all the time called space.
All right. I noticed a little penguin flying around with you guys. Like, is there a story about that?
So we get to have, there's a tradition, I think maybe the Russians started this, but the Demo 2 crew carried it on and brought a zero-G indicator with them on that first flight of the Crew Dragon. And so we've carried on that tradition, and basically it's a little friend that you can bring along, and then once you reach the, once your engine's all cut off, the little friend starts to float. So it's your zero gravity indicator, and we were able to, our sons chose this, myself and one other crew member have young sons, and so we asked them to choose something that they would like to see fly with us, and so they found Gwyn. This is Gwyn, our penguin.
Aww, that's adorable.
All right, so I know you guys touched upon this a little bit earlier, but so we've worked with some rocket engines, in industry and research, and the highest thrust levels we've kind of experienced are on the order of tens of thousands of pounds. And even that, kind of shook us to our core. So we were wondering, how does it feel and sound to be on top of a rocket putting out, over 1 million pounds of thrust?
Well, it feels incredible, as you might imagine. And the power, when the engine's lit for us just a few weeks ago, we were on the launch pad for a couple hours, first of all, but when the engine's lit, we all were so excited. It just felt incredibly powerful. We knew we were getting ready to go somewhere really fast. And then, of course, we're strapped in very tight. And then we just enjoy the ride for the next 8.5 to 9 minutes being on those engines. So on the SpaceX rocket, you may know there's 2 stages. So the first stage cuts off after about 2.5 minutes. And then we have a little bit of weightlessness before the second engine lights, and then a nice kick in the pants there to accelerate us for the next 6.5 minutes or so to get us into orbit. So it's hard to describe the whole thing. We're going in and out of about 3, sometimes almost 4 Gs throughout the ride, but it's not continuous.
All right. Thank you. And this is also kind of related, but how do you mentally prepare for liftoff? Like, what goes through your head during the countdown?
So we did a lot of training together. Shane and I, as the commander and the pilot, we spent a lot of hours in the SpaceX simulator preparing for the mission, for every phase of the mission, but the countdown and launch in particular. So we're listening for all of the calls, all of the talk that's happening with the launch control team, and we're talking, kind of reviewing things. Hey, if this happens, we'll do this. If this happens, we'll do that. But a lot of it, you're there for 2 hours before you lift off. So we're just, kind of keeping each other entertained between sort of more serious conversations. And so, the preparation doesn't come on that day. The preparation is something that you've been doing for years, really.
Awesome. Thank you. So, like I mentioned before, I'm currently, working on my PhD, and I know, Megan, that you did your PhD in oceanography. So I was wondering, what skills did you develop during the course of graduate school that helped prepare you to be an astronaut?
Well, I often talk about how oceanography and living in space can be very similar. So with oceanography, we go out to sea on ships. We have equipment that we're going to deploy and recover. And if something breaks on that equipment, you need to be able to fix it. You need to be able to get, all of the computers to talk to all of the equipment. So there's a lot of similar technical skills, and then there's some similar life skills. You're living in a contained environment with several other people who may or may not have the same habits as you. So there's some team skills and some life skills that you work on as well. So all of those things, I think, contribute to being prepared to being an astronaut.
All right, thank you.
So since you guys recently began your mission and launched last month, we were wondering kind of what the first 24 hours after docking are like, that transient period, maybe before getting settled in.
Hey, are you talking about before we docked or after we docked?
Either one. Just like the very beginning of the mission, like kind of that was like, yeah.
Like what the transition
Gotcha. Yeah.
Like.
So we had about 23 hours, I think, from launch. Yeah, from launch to docking. So that was a free flight, we call it. So on the way up to the space station, it was once we got to orbit, we were extremely happy. And then, we had a chance to get out of our spacesuits, kind of get kind of normal clothes on like this. And then we didn't have a lot to do, honestly, that day. There are a couple things we do with the checklist, but other than that, we're just kind of eating some food and getting ready for bed. We slept, or we were supposed to sleep at night. Megan and I didn't sleep so well that first night, but the other two slept great. And then we get our spacesuits on the next day to get ready for the docking and approach. So coming in, we had a beautiful, really no issues coming in to dock with the International Space Station. We docked on the very forward part. There was another Crew Dragon, which had docked to the Zenith. And so it was really neat to have two Crew Dragons dock to the space station at one time. Our friends left just, I guess, about a week ago now, almost a week ago, Crew-1, when they came home. So now we're getting busy up here, getting settled in, as you kind of alluded to before. With 11 people up here, it was a little hard. There was just people everywhere, and we weren't super efficient. But now we're getting settled in, so we can do the best work we can during the day.
All right. Yeah, just to kind of piggyback off of that. So you mentioned, sleeping is maybe a little bit of an issue. So how do you guys decide when to go to bed, and how do you kind of adjust your, circadian rhythms to get on schedule?
So there's a couple of answers to that question. One, when we launch, our circadian rhythm has to be set to launch time. And so our launch was really early in the morning, which meant we had already worked for many hours before the actual launch time. And so we had sleep shifted. I think we were going to bed at like 2 p.m. Eastern time in order to be awake in time to get ready for the launch. So our sleep schedule is already a little bit messed up. The International Space Station operates on Greenwich Mean Time. And so right now we're waking up and it's about midnight in Houston, which is where the Mission Control Center is. And so we had to then again adjust to that time. And our planners on the ground write a very, very detailed plan for us every single day. Our day is scheduled, pretty much every minute of our day is scheduled. We do get some what we call gray space, which means there's no colored task on the task or on the schedule that we have to finish. Our meal times are scheduled, and then typically we're given a sleep period that starts at about 9:30 p.m. So it's we are allowed to choose whether or not we want to go to bed then, but it's a pretty good idea because you're going to be up early the next morning and at work again.
All right. Well, we want to thank you so much for taking time out of your busy mission to chat with us. And our last question is more of a fun one. What is the best space station inside joke?
There's probably several that I'm not aware of, but a few that I have heard of is people set traps for people when you're flying around. And so people that aren't so great at flying, like the new folks maybe, you can set traps for them and they'll get caught in them. So that's just one little thing that I've heard has been done.
All right. Yeah, thank you so much for taking time out of your day to chat with us. Really appreciate it.
Yeah, best of luck on the rest of your mission, and go Bruins.
Absolutely. Anil and Annalise, thanks for joining us. The Bruin engineers, thanks for joining us. And, of course, go Bruins!
Station, this is Houston ACR. Thank you. That concludes our event.
Thank you to all participants from UCLA. Station, we are now resuming operational audio communications.